for convenience of customers, this precaution and measure were used to show how this new product was made in the laboratory. Hence, the following up complication. Oxygen groups in chocolate lab. Lab number 3 of the year. Laboratory group 11A. Co-workers Manuela Rondón, Isabela Loaiza, Camila Ortiz, and Laura Ruiz. Leader of the group Miguel Ángel García. Experiment day 6th of November of 2025. Lab report 9th of November of 2025. Safety considerations. Wear lab coats, gloves, and use a mesh for your hair. Heat the chocolate with precaution.
Basically, the summary of this lab is that we sought to better understand oxygenated functional groups, the alcohols, the aldehydes, and the ketones, which were the ones that we saw in class and their structures, and how they are present in foods we consume every day, for example, the chocolate. To make this more practical and more attractive, we conduct an activity where we prepare personalized chocolates, choosing us to use chocolate-covered gummies and chocolate-covered popcorn. While we were working on the culinary part, we connect this to the chemistry. The chocolate gummies and the popcorn are primarily made of carbohydrates and other organic compounds that can contain these oxygenated groups. For example, sugars that are present in the chocolate and in the gummies have many alcohol groups. Some aromatic compounds can have aldehyde or ketone structures. And in general, processed ingredients include molecules with these groups that can influence their flavor, their texture, and, so important, how they react to the heat. The idea of the experiment was that through something as simple as preparing a chocolate with a distinctive mark, we will recognize in which part of those foods the alcohol, the aldehyde, and the ketones groups can appear, and reinforce what was seen in class from more concrete and everyday experience such as cooking.
Keywords: gummies, chocolate coating, mass change, food coding, and sensory evaluation. General objective: to determine how oxygenation will affect the quality and composition of the homemade chocolate, in this case, gummies covered with chocolate and popcorn covered with chocolate. Specific objectives: to measure the level of oxygen exposure during the chocolate making processes, to analyze how oxygenation will influence the texture, color, and taste of the chocolate, to compare chocolates made under different oxygen exposure levels to identify which condition will produce the best quality.
Chocolate and gummy candies are composed of organic compounds that contain oxygenated functional groups such as hydroxyl, carbonyl, and carboxyl. These groups are responsible for many of the chemical and physical properties observed during the coating process. For instance, the hydroxyl groups in sugars form hydrogen bonds that affect melting point and solubility, while carbonyl groups in cocoa butter and fats influence crystallization and texture. Understanding these oxygenated functional groups helps explain the structural transformations that occur when the chocolate melts and solidifies around the gummy surface. In gastronomy, chemistry plays a fundamental role in understanding and controlling textures, flavors, and physical stability in desserts and confections. The process of coating gummies with chocolate exemplifies how chemical reactions and molecular interactions can be used to create new products with desirable sensory attributes. Chefs often apply concepts related to phase changes, viscosity, and emulsion stability, all linked to the functional groups present in the ingredients, to achieve uniform coatings and appealing presentations. In everyday life, oxygenated functional groups are present in many common products beyond food, such as perfumes, cleaning agents, and medicines. In the case of confectionery, these compounds determine the flavor, aroma, and preservation of sweets. The experiment of chocolate coated gummies connects academic chemistry to daily experiences, showing how molecular properties share the foods we consume and the sensory experience they provide. Ultimately, it demonstrates that chemistry is not limited to the laboratory. It is a science that explains the transformations we observe, taste, and enjoy every day, making our understanding of food both scientific and deeply human.
In our experiment, we focused on oxygen-containing functional groups in chocolate. Alcohols found in sugars of gummies give sweetness and help dissolve them. Carboxylic acid are present in the fatty acids of cocoa butter, influencing the melting point and smooth texture of chocolate. Esters forming from alcohols and acids create a pleasant aroma and flavor. Understanding these groups helps explaining how heating and cooling affect the structure, texture, and taste when making chocolate-covered gummies and popcorn.
And the popcorn. To prepare our chocolate-covered popcorn, first gather all the necessary materials and ingredients. Pre-made popcorn, unsalted and unflavored, melting chocolate, a heat-proof bowl, a spatula, a baking sheet lined with a parchment paper. Once everything's ready, we'll begin by melting the chocolate using a double boiler. To do this, heat water in a saucepan and place the chopped chocolate into a bowl, which you will then place over the saucepan, making sure it doesn't touch the water directly. As the hot steam rises, stir the chocolate with the spatula until it's completely melted and has a smooth, uniform texture. When the chocolate is ready, let it rest for a few minutes to cool slightly and become lukewarm, preventing it from burning or softening the popcorn too much. Then, in a large bowl, pour the chocolate over the popcorn and gently mix with the spatula to ensure all the popcorn is evenly coated without breaking it. After this, spread the chocolate-covered popcorn onto the lined baking sheet, making sure to separate them slightly to prevent them from clumping together. Unlike other methods, we won't refrigerate them. We'll simply let them sit at room temperature until the chocolate has completely hardened. Once the coating is firm, the popcorn is ready to serve or store in an airtight container to keep it fresh and crispy. Okay, so to prepare our chocolate-covered gummies, we first gather all the necessary materials. We use strawberry gummies and choose milk chocolate, along with a heat-proof bowl, a spatula, a baking sheet, and a parchment paper. Then we began melting the chocolate using a double boiler. To do this, we heat the water in a saucepan and place the chopped chocolate into a bowl, which we then place on top of the saucepan, making sure the bowl didn't touch the water. As the steam heated the bowl, we stirred until the chocolate was completely liquid and has a glossy finish. Once melted, we let it cool slightly so it wouldn't melt the gummies. Then we began dipping them one by one using a fork. We dip each gummy into the milk chocolate, making sure it was well coated and removing any excess before placing it on the baking sheet, lined with a parchment paper. We let them sit at room temperature on the tray until the chocolate solidified on its own. This way, the coating set without needing any additional refrigeration, and we will watch the chocolate harden gradually. Once they were all firm, they were ready to serve or store in an airtight container.
In our lab about oxygen-containing functional groups, we analyzed how these chemical groups influence the behavior of chocolate when mixed with gummies and popcorn. During the experiment, we observed that the chocolate melts easily when heated and solidified again when it's cold. This is because cocoa butter contains carboxylic acids and esters, which are responsible for its low melting point of smooth texture. When the melted chocolate was poured over the gummies, the surface softened but did not dissolve completely. This is due to the presence of alcohol groups in the sugars that make up the gummies, which give them partial solubility and flexibility. In contrast, the popcorn stays solid and slightly brown after being coated, showing only a physical change without any chemical reactions. None of the materials react with acids or conduct electricity, which confirms that the process may involve physical transformations rather than chemical ones. Overall, the results show that oxygen groups such as alcohols, carboxylic acids, and esters play an important role in determining the melting point, solubility, aroma, and texture of chocolate-based mixtures. Understanding these interactions helps again why chocolate behaves different when used with ingredients like gummies or popcorn.
Proteins like peptides, and these are from cocoa solids. And the carbonyl group, a carbon and an oxygen present in aldehydes and ketones that give chocolate its aroma.
So the other components of the chocolate are the ether group, the oxygen found in complex carbohydrates and flavoring compounds, Then is the phenolic group, carbon 6, hydrogen 4 OH, present in polyphenols and flavonoids responsible for antioxidant properties. Then is the methyl group, carbon hydrogen 3, found in caffeine
Finally,
and
we can
theobromine,
conclude
natural
that
stimulants in the
oxygen-containing
cocoa.
functional groups have a
Then is
strong
the amino
influence
group,
on the
nitrogen
physical
hydrogen
and
2,
sensory
present in
properties of
amino acids
chocolate.
from cocoa
The
proteins.
presence of
And finally
carboxylic
is the
acids
alkyl
and
group, a
esters
double
in
bond
cocoa
between
butter
carbons
explains why
found
chocolate
in
melts
unsaturated fatty
easily
acids within
and then
cocoa butter,
solidifies
like the
again with a
Lakers.
shiny and smooth texture. Alcohol groups in the sugar of the gummies allow partial solubility, which is why they soften when covered with hot chocolate but did not dissolve completely. The popcorn, on the other hand, remains solid, showing that its compositions contains fewer oxygenated groups and that the changes were mainly physical. The results confirm that the interaction between oxygenating functional groups determines characteristics such as flavor, aroma, textures, and melting behavior. Understanding these relationships help us connect the chemistry with food science, showing how molecular structures directly influence and quality and experience of chocolate-based products.
With teacher Juan, and he's gonna taste our gummies with chocolate. In our lab of chemistry, we work with the oxygen compounds in chocolate.
Delicious.
So 1 to 7, how do you taste it?
It's so delicious. I like it. For me, I'm 7.
Okay, for texture.
That's it for me.
Science never tastes this good.